Hai guys, Assalamualaikum. Okay, selamat sejahtera. Okay, so today kita continue dengan topik a little bit series and binomial theorem. Okay, so share screen. Okay, so this is where we last stop. Okay, which is at s infinity. Okay, sums to infinity. Okay, so this is the formula. Okay, sum to infinity equal to a over 1 minus r. Okay, so a is the first term and r is the common ratio. Okay, so let's look at the example 6.14. Okay, so we have to find the sum to k terms, okay, of the following series. Okay, question A and B, and reduce their sums to infinity, which means we have to find the s infinity. Okay, so for question A, okay, so this is the question A. So I just write again here. Okay, 1 plus 1 over 3 plus 1 over 9 plus 1 over 27. Okay, so this one is A. Okay, this one is A, the first term, and then the common ratio is, okay, so this one have to multiply with 1 over 3. So this is R. Okay, so we know that A is 1 and then R is just that color, I guess. So R is 1 over 3. Okay, so then we just write again the formula, which is, okay, so this is the formula. S sum to infinity equal to A 1 minus R. Okay, and then we just plug in. A is 1, okay, and then R is 1 over 3. Okay, so then this 1 2 over 3. So we just so it will be 3 over 2. Okay, and then for R, okay, and then for the, okay, that's it. That's the answer. Okay, sums to infinity is 3 over 2. Okay, next for B, this will be 12 plus 6 plus 3 plus 1 over 2. Okay, so this one is 12 6 plus 3 and then plus 3 over 2. Okay, so which one is A? Okay, so this one is A, the first term. Okay, and then for R, okay, so we identify that it is to get 6 here, 12 multiply with 1 over 2. Okay, must remember in term of ratio. Okay, so this one 1 over 2 as well, and then so this is the R. Okay, and then input to the formula. Okay, sum to infinity A 1 minus R. Okay, so A is 12, R is 1 over 2. Okay, so 12 1 over 2. So we get 24. Okay, sum to infinity is 24 for the question B. Okay. Okay, and then wait, I have to take my phone. Oh, here. Okay, and then next, okay, we are going to what is it? Subtopic of binomial theorem. Okay, so binomial theorem. Okay, so yeah, now into binomial theorem. Okay, so what is binomial theorem? Okay, so it is about something like to deal with equation. Okay, so you can see here. Okay, if you want to show the expression of a plus b in bracket to the power of 2 can be written as a squared plus 2ab plus b squared, right? Okay, so it's easy. Okay, same goes to the a plus b in bracket to the power of 3. Okay, which we can write down in terms of a to the power of 3 plus 3a squared b plus 3ab squared plus b to the power of 3. Okay, so how about if the power goes more than 3? Okay, let's say 10. Okay, so it must be quite difficult to write one by one. Okay, so this is binomial theorem is quite a simple technique. Okay, for expanding expressions of the form a plus b to the power of n. Okay, so n here is positive integer. Okay, so we can use Pascal's triangle. So this is the Pascal triangle. Okay, Pascal's triangle. Okay, so okay, here, okay, the third row. Okay, the third row which is here. Okay, 1 to 1. Okay, 1 to 1 is the expansion of a plus b to a plus b. Is the expansion of a plus b squared. 1 to 1, right? Okay, so this is the third row. Okay, so here is okay 1 to 1. Okay, and then we just plug in the a a a. Okay, so this one will be a 0. No, oh, this one is increasing. Okay, so a to the power of 2 1 0. Okay, and then b 1 b 2. So what I'm going to say here is what I'm trying to say here is okay, here okay, one more time. Okay, so 1 to 1, right? Okay, 1 plus 2 and then plus 1. Okay, so that's the number given from the Pascal's triangle. And then how to write A and B. Okay, so for A will be and it will be decreasing. Okay, as it goes from to the left to right, it will be decreasing. So the highest power is to right. Okay, and then here it will be decreased to the power of 1. Here will be 0. Okay, and for B, okay, B, it will be increasing as it goes from left to the right. So start with B0, B1, and B2. So how are we going to write it? So it will be 1 A squared plus 2 AB plus 1 B squared. Okay, so that is how we are going to write the AB. Okay, okay, so here you can see, okay, for row is given 1 3 3 1. Okay, so again, how we are going to write this one? Okay, so okay, 1 3 1, isn't it? Okay, so again 1 3 3 1. Okay, so A, as A goes from left to right, it will be decreasing. Okay, so this is, okay, if you want to know what is the power of each row, you just this one. Okay, use this one. So this is the power of 1 to the power of 1 to the power of 2. Okay, so to the power, okay, 3 4 5 6. Okay, so since this is 3, okay, to the power of 3, so A start with 3. Okay, and then A2, A1, A0. Okay, at the end it must be 0. Okay, A0. Okay, this is the keyword. Okay, and then for B, B also must start with B0. Okay, as B, as it goes from left to right, it will be increased. Okay, so BO, B1, okay, B1, B2, and B3. Okay, so for then how we are going to write it? So it will be 1 A3 plus 3 A2 B1 plus 3 A B2 plus 1 B3. Okay. Okay, so Pascal triangle, how it is formed. Okay, so as you can see here, let's say this. Okay, so you start with 1. Okay, and then this is the basic form 1 1 1. Okay, so at the end it must be 1. Okay, as well as here. Okay, at the end it must be end with 1, start with 1. Okay, so for the third row, again start with 1. Okay, so and then okay, so this is 1. Okay, so now what's the number here? So this one must plus this one, so it can form the number here. So it will be this one. So it will be 2. So and then cover up with 1 here again. Okay, and then next. Okay, next. So this is to the power 1. Okay, so next again with 1. Okay, so this one. Okay, so this one and then this one. Okay, plus should be what? 1 plus 2 is 3, isn't it? Okay, so it will be 3 here. Okay, and then this one also. Okay, so this one plus this one, so it will be 3 and end with 1. Okay, and with 1. Okay, okay, so next, so start with 1. Okay, and then this one plus this one, so it will become 4. Okay, and then 3, this one, it will become 6. Okay, and then this one plus this one, so it becomes 4, and the end also will become 1. Okay, so that is how we form the Pascal's triangle. Okay, okay, so next. Okay, so now we are going to this example. Okay, okay, use Pascal's triangle to expand a plus b to the power of 6. Okay, so from Pascal's triangle, the number is, okay, so 6, isn't it? Okay, so the power of 6, so it will be this one. Okay, to the power of 6, right? Okay, so this one. Okay, 1, 6, 5, 15, 20, 15, 6, 1. Okay, so just write here. Okay, okay, so we just, I think where I just show here. Okay, so the number is this one. Okay, so just from the Pascal triangle below, above, sorry. Okay, so 1, 6, and then 15, and then 20, and then 15. Maybe I should use different colors. Okay, I take purple. Okay, 1, 16, sorry, 6, 6, 15, 20, 15, 6, and 1. Okay, so again, so this is A and B, right? Okay, so this is A and B. Okay, make sure the number or any letter used there. Okay, so we start with A. Okay, so A, remember for the first letter or integer, it will be, okay, from left to right. Okay, what is going to be decreased? Okay, so the highest power is 6, right? Okay, is 6. Okay, so we start with 6 and then decrease to 5, 4, 3, 2, 1, and 0. And then next is B. Okay, so from left to right, it will be increase. Start with 0, 1, 2, 3, 4, 5, and 6. Okay, so how we are going to write it? So it will be, okay, A6 plus 6A5B1 plus 15A4B2 plus 20A3B3 plus 15A2B4 plus 6AB5 plus B6. Okay, so that's how to write it. Okay, as the answer shown here is just the same. Okay, and then for next example. Okay, so here It's just the same. Okay. Expand 1 plus x to the power of 7 using Pascal triangle. Okay, so now we don't have 7, so we have to what we call it, we have to form the Pascal's number on our own, and then notice that a and b have been changed to 1 and x. Okay, so now we are going to do Pascal's triangle. Okay, so before this, you know that for to the power of 6, this is the number. Okay, 1, 6. Okay, 6, 1, 6, 15, 20, 15, 6, and 1. Okay, so now we are going to add the new row, which is to the power of 7. Okay, so to the power of 7 will be this, to the power of 7. Okay, so this one will be 1. Start with 1. Okay, and then this one plus, so it will be 7. Okay, and then plus this one, so it will be 21. Okay, plus this one, it will be 35. Okay, and plus 20 plus 15, 35 again. Okay, okay, plus, so this one will be 21. Okay, and then 6 plus 1, it will become 7, and then end with 1. Okay, so this is row for to the power of 7. Okay, so now we are going to write the number. Okay, so remember you have to check what is the a and b. Okay, so a here is 1. Okay, so we just write down 1, okay, instead of a. Okay, so this is 1. Okay, and then remember from left to right it will be decrease. Okay, so the highest power is 7, right? Okay, so 7, so just write down 7. Okay, but what power is it? It still maintain 1. Okay, 3, 2, 1, 1, 1, 0. So it doesn't affect too many. Okay, and then the next number, which is b. Okay, now b has been changed into x. Okay, so x, so from left to right it will be increasing. Start with 0. 1, 2, 3, 4, 5, 6, 7. Okay, so now we are going to write the whole equations. So once again, the equation is 1 plus x close bracket to the power of 7 is, okay, so now you're going to write 1. Okay, so x0 is 1. Okay, and then 7 x1 plus 21 x2 plus 35 x3 plus 35 x4 plus 21 x5 plus 7 x6 plus x7. Okay, so same, isn't it? The answer Okay, so that's it, how we are going to write to the power of 7. Okay, next. Okay, so if n, we go for large n, so it will be difficult, right, to go for Pascal triangle. So we have to use this formula. Okay. Okay. So here. Okay. And it is necessary to expand the quantity for large n. So we have to use this one. Okay. Okay. Still just the same. Okay. So I just copy and paste this one. So here we can see that, okay, first there is n. Okay. And so n here is 1. Okay. This one is n0. It's okay. And then as it goes from left to the right, so n minus, okay, n minus 1 to the power of 2, and then this one n minus 1, and then we have an extra n minus 2, and then 3. Okay, and then we have a. Okay, so this is the a. So a, we can see a start decreasing, n minus 1, n minus 2. Okay, n minus a to the power n minus 3. So it will be keep decreasing for a. Okay, and then for b, you can see b here is 0. So b here is 1. Okay, b2, b3. So b keep increasing. So it's just the same. Okay, so again, I have to write here n, okay, 0 plus n, 1. Okay, and then plus n, we have extra n minus 1, 2, plus n minus 1, n minus 2, and when we have 3. And then for a, okay, a, as usual, as it goes from left to right, it will be decreasing. So to the power of n, an minus 1, an minus 2, an minus 3. And then we have letter B, alphabet B. Okay, so B, for B, as it goes from left to right, it will be increased. So B0, B1, B2, B3. Okay, simple. Okay, so we go for example 6.17. Okay, so this one, okay, expand 1 plus x to the power of 10, okay, up to term in x to the power of 3. Okay, so we just have to write the, what is it, the formula. Okay, so the formula is 1 plus x to the power of n. Okay, okay, so it will be, okay, so n here is 0, n, okay, plus n, and then we have plus n minus 1 over 2. Okay, and then we have n minus 1, n minus 2, 3. Okay, and then we have a as 1. Okay, this is will be the a. So a 1. So it's okay. I guess we have to write the general formula first. Okay, so this one is a will be n, and then a n minus 1. and then a n minus 2, a n minus 3. Okay, and then maybe we have to write in term of 1. Okay, I guess. So let's see. We just write in term of 1. Okay. So a is 1. Okay. So 1. So okay. So n here. How I'm going to say? Okay. 1n. Okay. And then 1. Okay. N minus 1. N minus 2. 1. N minus 3. Okay. And then we have x. Okay. Oh, I think wrong. Okay, so this is the E. Okay, so just 1n, 1n minus 1, 1n minus 2, 1n minus 3. Okay, so as it is 1, so it doesn't affect much. Okay, so it will maintain as 1. Okay, so and then for B is x. Okay, so B will be increasing. Okay, start with 0, 1, 2, and 3. Okay, so up to the power of 3, right? Okay, according to the question, yes, up to the power of 3. So we stop here. Okay, and then n here. Okay, n here is given as 10. Okay, so we just plug in the, just change n to 10. Okay, so will be here n is 0, so this is 1. Okay, and then plus 10 x1, okay, plus 10, 9, then 2 x2, and then 10, 9, 8, and then this is 6. Okay, this one is 3 minus 2. Okay, minus, sorry, multiply with 1. This is 2 multiply 1. Okay, factorial, they are multiplying with smaller number. Okay, until 1. Okay, and then this one, don't forget, x to the power of 3. So 1 plus 10 x plus 45 x to the power of 2 plus 120 x to the power of 3. Okay, so this is the answer. Okay, then okay, so let me see next example. Okay, so this is let's say the power is negative. Okay, okay, so this is example 6.18. Okay. Okay, use binomial theorem to expand 1 over 1 plus x. Okay, up to x to the power of 3. Okay, so again, you just write down the, what is it, the general term. Okay, okay, so 1 plus x to the power of n. Okay, So it will be for n and 0 here plus n 1, okay, plus n minus 1. Okay, it's okay lah. Okay, and then 2. Okay, and then plus n minus 1 and minus 2, 3. Okay, and then for 1, okay, 1 it will be decreasing. Okay, as we it replace a. Okay, so it will be decreasing. 1n minus 1 n minus 2. Again, as it is 1, so it doesn't affect much what power is up to. Okay, then x. Okay, so x here will increase. Okay, so x0, x1, x2, x3. Okay, the question only just up ask us to write the equation up to x to the power of 3. Okay, so now, okay, oh, I forgot. Okay, before that, this one, okay, you can write in terms of this one. So it will be -1. Okay, because this fraction here, where we want to bring this up, so this one will be equal to -1. Okay, okay, so here n is -1. Okay, and here is -1. So we just write down here. So this one is 1, okay, plus -1, and then we have x. Okay, and then this one -1. Okay, -1, -2. Okay, so this one is 2 x to the power of 2 plus, okay, -1, and -2, -3. Okay, and then this one 3 multiply with 2 x3. Okay, simplify. 1 minus x, okay, plus x squared, because cancel this one, and then minus, cancel, x3. Okay, so this is the answer. The same. Okay, plus and minus, plus minus. Okay, okay, so okay, this one, I think the last example. Okay, so the question, okay, question, obtain a quadratic approximation. Okay, for this one, okay, using binomial theorem. Okay, quadratic mean up until x squared. Okay, okay, so we have to use the binomial theorem. Okay, we just write down the basic formula, which is, okay, so here we have to, okay, 1 plus x, and okay, this one 0, and 1 plus n minus 1, 2. Okay, and then plus n minus 1, and minus 2, 3. Okay, and then okay, 1 doesn't matter, so I think we have to skip 1 because it doesn't matter. So we just go straight for x. Okay, x, it will be increasing, so x0, x1, x2, x3. Okay, since it asks quadratic approximation, which is only up to x to the power of 2, we can ignore the last term here. Okay, so now given here is 1 plus, minus, right? Okay, 1 minus 2x to the power 1 of 1 over 2. So therefore, and here is 1 over 2, and x here is negative 2l. So we have to convert n and x here. Okay, so for n, okay, for the first term, it will be just equal to 1 and then plus 1 over 2 and then negative 2x. Okay, and then this one plus 1 over 2. Okay, this one will be 1 minus 1 over 2 will be equal to negative 1 over 2. Okay, and then this one is 2. Okay, so for x is negative 2x squared. Okay, so this will be 1. Okay. Okay, I think my laptop has heat up so much. Okay, so 1. Okay, and then minus, minus. You can write down. So how I'm going to, okay, minus, okay, x. So I think we have to continue in next lecture, I guess. Okay, so I think that's it. To end the class here.